Friends, welcome to the third video of quadratic equations. We are still studying the basic concepts of quadratic equations. This is the third video in the series. I will strongly urge you to watch the previous two videos because without those two videos, you're not going to understand a lot of things in this video. Okay, the link to the previous two videos is down there in the description. The entire playlist link is there in the description, so you can refer to the entire playlist. Okay, let's start solving this one or studying about this one. So in this video we are going to study about the nature of roots of a quadratic equation. First, we have studied that what is the standard form of a quadratic equation. It is ax square plus bx plus c. This is the standard format of a quadratic equation. So whenever you are given a quadratic equation, immediately in your mind map the equation to this format, which is ax square plus bx plus c. Okay, now we have a term which is called discriminant, which is denoted by d. Okay, the discriminant of a quadratic equation denoted by d is equal to b square minus 4ac. Okay, in the future videos I'll also tell you why it is this value and how did we arrive at this value and what is the utility of this value. But to appreciate the usefulness of this term d, please wait a little. Okay, first understand what it is. So in a quadratic equation which is denoted in its standard format by ax square plus bx plus c equal to 0, the value of the determinant is equal to b square minus 4ac. Okay, and this is the determinant of a quadratic equation, always denoted by b square minus 4ac. Now if the value of d is greater than or equal to 0, it will have real roots. Okay, and if d is less than 0, it will have imaginary roots. Okay, a lot of places also called imaginary roots as no real roots, which are the same thing. Okay, no real roots. This is one way of looking at this. Another is if d is equal to 0, then the equation will have equal roots, and if d is not equal to 0, it will have unequal roots. Okay, so one way of thinking is whether the roots are real or not real. Okay, real or not real. Another way of thinking is whether the roots are equal or not equal. Okay, now imagine d is equal to 0. If d is equal to 0, then you see we have know that roots are equal and d is greater than equal to 0 has real roots. So if d is equal to 0, then we have real and equal roots. Okay, you should revise these concepts really well so that these values become second nature to you. Okay, the value of d decides whether the nature of the roots is real or unreal or imaginary or equal and unequal. Okay, so now we have studied what is the value of d, discriminant of a quadratic equation. We have studied what is real and unequal roots. We have studied real and equal roots and what are imaginary roots. Okay, so if I combine these two cases, let us try and understand these values through an equation. Let's take the first question. Okay, let's take the third question first, the third example first, because it is here. X square minus 4x plus 3. Okay, in this question I compare the coefficients, okay, with ax square plus bx plus c. What I find is a is equal to 1, because what is accompanying x square is 1. Okay, I only look at the coefficient of x square as a. Okay, so x square coefficient is 1, so a is 1. The value of b is minus of 4 and the value of c is 3. Okay, so I have abc. If I have abc, what is the value of d? D is equal to b square minus 4ac. B square is 16. Okay, minus 4, a is 1 and c is 3. So 16 minus 12 is equal to 4. Okay, 16 minus 12 is 4. Now look at what is the value of d. In example 3, if this is the quadratic equation, then what is the value of d? d is equal to 4 and d is equal to 4 is greater than 0. Okay, d is equal to 4 is greater than 0, which means the roots are real or imaginary. They are real. Equal and unequal, they are unequal. They are unequal. Okay, now let's take example 1. Okay, let's take example 1. Example 1 is x square plus x plus 1. Let's take example 1. It is x square plus x plus 1. Let us compare this to the standard form of a quadratic equation. Ax square plus bx plus c. So what is the value of a is 1. What is the value of b? It is 1. What is the value of c? It is 1. Okay, coefficient of x square is a, coefficient of x is b, and constant term is c. So a is equal to 1, b is equal to 1, c is equal to 1. Now what is the value of d? D is equal to b square minus 4ac, and this will be equal to 1 minus 4 into 1 into 1, which is equal to minus of 3. Now you see, I'll draw a line here. Now you see d is equal to minus of 3. The moment d is less than 0, what do we know? The roots are not real. Okay, and the roots are not real and not equal. I hope you understood. I've taken an example wherein d is greater than 0. I've taken an example where d is less than 0. Now let's solve example 2. What is example 2? Example 2 is x square minus 2x plus 1. So x square minus 2x plus 1. Compare this to the standard form, which is ax square plus bx plus c. What is the value of a? A equal to 1. What is the value of b? B equal to minus 2. What is the value of c? C equal to 1. So you see b square minus 4ac is equal to b square is 4, 2 square is 4, minus 4 into a, which is 1, into c, which is 1. This becomes 4 minus 4 is equal to 0. So the value of d, which is b square minus 4ac, is equal to 0. If d is equal to 0, then the roots are real and they are equal. Okay, so I will quickly summarize all the things that we studied. We studied what is the discriminant of a quadratic equation, denoted by d. It is equal to b square minus 4ac. If it is greater than 0, if d is greater than 0, then roots are real and unequal. If d is equal to 0, then the roots are real and equal. If d is less than 0, the roots are imaginary and they are unequal as well. Okay, I hope you found this useful. We are going to solve a few more theoretical concepts of quadratic equation in the coming videos. I will strongly urge you to subscribe to this channel.